I'm Anil Kumar. Welcome to my series on exponential and logarithmic functions. In this video, we are sharing with you an excellent test question. A square ABCD has area 36 and AB is parallel to x-axis. Vertices A, B, C are on the graph of y equals to log to the base a of x, y equals to 2 times log to the base a of x, and y equals to 3 times log a x, respectively. What is a? You can always pause the video, answer the question, and then look into my suggestions. Now let's try to understand the situation. We are given 3 different graphs. So let us say that this is a log function which is log to the base a of x, right? Let's say this is log to the base a of x. Now if I vertically stretch it by a factor of 2, then we get the other function, which could be kind of like this. So we'll call this as 2 times log to the base a of x, and stretching it 3 times will give us the third curve, which is going to be kind of like this, right? Let's say 3 log to the base a of x, right? Now the question says that ABCD has an area of 36. So we have a square area equals to 36. That means sides are 6, right? So each side is 6. So that means on this graph we have a point AB which is parallel to the x-axis, right? And the vertices A, B, and C are on graph. A is on y log to the base ax and B is on 2, right? So let us say we have this AB as kind of like this. So A is on this graph, B is on this graph. So what we could do here is we exactly know that 6 centimeters or 6 units. So from this we can go 6 units up somewhere. It is going to touch this particular graph, and then we can complete our square, right? So we can form a square with 6 units in this fashion, where the point C lies on the graph of 3 log ax. Is that clear to you? So that becomes the situation. Now it really means that each side here is 6 units. So this is 6 and that is also 6 units. Now that should help us to find the solution. So the difference between the y values of C and B, that means the height CB. So let's find what is CB equals to, right? So CB is the difference of values between the graph of 3 log ax, right, minus 2 log ax. Base is A, right? So that is what it is. And we know that CB is 6 units, so we can write this as 6 equals 2. And here we can apply the rules. We get log to the base a of x cubed, right, minus log to the base a of x squared, and then 6 is equals to log to the base a of x cubed over x squared, right? So that gives you 6 is equals to log to the base a of x, right? So the x square cancel. And from here we can say that a to the power of 6 is equal to x. So we get one condition about x, and that is x is equals to a to the power of x. Now we also understand that the horizontal distance is also 6, that is b to a. So let's work on this b to a distance. So b to a is equal to what? Now b to a is the difference in the value. So here if x is x, at this place the x value is x plus 6. However, the y values are same, right? So So that really means from B to A, which is y values are same, right? So B to A means same y values, correct? That is to for these two graphs, right? This is y equals to 2 log ax, that is y equals to log to the base ax. So at x equals to x plus 6, for log ax, the value should be, the difference should be 6, correct? That's what we're trying to say, right? Okay, so that really means that the y values are same for y equals to, for this point at x, right? So for log 2, log to the base a of x is equal to log to the base a of x plus 6, right? Since this line is parallel to x-axis. So the y values will be same, right? So when we shift by 6 units to the right, y values will be same. So y value for this and that, these 2 points, right, has to be exactly same. So that should give us the second condition. Okay, so that really means that we could write this as log to the base a of x square equals to log to the base a of x plus 6, or we get x square equals to x plus 6. Bringing them together, we get x square minus x minus 6 equals to 0. 3 times 2 is 6, so we could write this as x minus 3 times x plus 2 equals to 0. So that gives us x equals to 3, a valid x has to be positive. Since for logarithmic functions, we know x has to be greater than 0. So x equals to negative 2 is not valid. So we get a value of x which is 3, right? So we have a value of x which is equal to 3. Now using this value of x in our first equation, let's call this as our first equation and this one as our second, we can substitute the value of x here and find a, right? So we get a, which implies here a is x to the power of 1 over 6, right? Rearranging. So a is 3 to the power of 1 over 6, correct? Is that clear to you? So what is the value of a? A is 3 to the power of 1 over 6, correct? So that is our answer, which is a equals to 3 to the power of 1 over 6.